In radians, how much larger is an interior angle of a 10-sided regular polygon compared to that of an 8-sided regular polygon? Well, to get started, I should probably figure out how many degrees are in a polygon of n sides. There's a formula for that. It's supposed to be the case that if a polygon has n sides, it's supposed to have 180 times n minus 2 degrees. That being said, I do notice that the question is not asking us for degrees, it's asking us for radians. So even though I could convert to radians later, it might save us a little bit of time to actually convert this to radians straight away. Using the fact that 180 degrees is the same thing as pi radians, then I might say that my 180 degrees, well, cancel out what that conversion factor is 180 degrees on the bottom. That tells me that when I have n sides in a polygon, that corresponds to pi times n minus 2 in radians. That looks a lot better. Furthermore, we're talking about a single interior angle in each shape. Now, in general, shapes could have angles of many different measures. Because we see the word regular, that means that all angles in the same shape are going to be equal. So I think about each angle in the shape. That tells me that I can take the number in radians and then divide that by each of the n sides. Now I have a formula to simply do the calculations pretty quickly. If I want how much larger the interior angle of a 10-sided regular polygon is versus the 8-sided regular polygon, all I have to do now is plug in 10 into the first expression, subtract what happens when I plug in 8 to the second expression. A little bit of algebra, but this is definitely something that we could do. We get 8 pi over 10 minus 6 pi over 8. And if we simplify this, looks like we're going to get 4 pi over 5 minus 3 pi over 4. Common denominator of 20 means that we're going to get 16 pi over 20 minus 15 pi over 20. Of course, that's going to be equal to pi over 20 in radians, so that's our answer.